Hey gang, Stat 1150, proportions and hypothesis testing. As problems get tougher, as I think they've done last week, within the last week or so, I think it helps sometimes to for me to work some problems uh, as demonstration like the ones that you encounter on your homework assignment. So that's what I'm going to do today, or at least in this video. It's work problems exactly like you're going to encounter on my math lab. It's one thing to teach in theory. It's one thing to give maybe these abstract examples or abstract concepts. But I think it sometimes bridges the gap when you can see me work the problems that you're going to be held accountable working. So, guys, let's get to it. If I go to my math lab, which I have right down here, there is an assignment up called homework demo do not demo only do not do, and so what I want to do here is just work the problems and talk them through. So it's more than just getting the right answer. It's me explaining to you why some of the answers, which may seem reasonable to you at this point, because again you're still learning, why those aren't the correct answer. So let's get going. So question number one says that a research hospital tries a new antibiotic scrub before surgery to see whether it can lower the rate of infections of surgical sites. The old rate of infection is 4.4%. So guys, the null hypothesis would be H sub O P equal 0.044. But the intent of this question is report the alternative hypothesis in words and in symbols. So the alternative hypothesis is always this HA. So anything down through here that doesn't say H sub A couldn't be a candidate for the answer. Now, something else that can't be a candidate for the answer is when it says of the next 1,000 surgeries. Guys, important point. Listen closely here. Null and alternative hypotheses speak in terms of parameters. They speak in terms of an overall statement for the population. So right off the bat, I can get rid of B, I can get rid of C, and I can get rid of E because they're talking about a sample which is just the next 1,000 surgeries. Now granted, it wouldn't be a random sample, it'd be a convenience sample, but nevertheless, an alternative and a null hypothesis or hypotheses do not pertain to a certain sample. It pertains to a statement about a population. Well, guys, up here, when we see that keyword lower, I know right off the bat here that I need to look for less than. So I'm going to check my answer. It's going to be right. Fantastic. Cool. Now, report the alternative hypothesis in symbols. Well, guys, we need a P. P hat deals with a sample. P deals with a claim about a population. And again, null, you know it's important if I'm going to repeat it to you like 15 times. Alternative and null hypotheses deal with populations, statements about populations. And we want less than 0.44, check it. It's going to be fantastic again. Let's go give it, actually be excellent in this one, okay? So the next question, question number two, a magician claims he can use a coin to come up with heads more than 50% of the time. The coin is flipped 40 times and 29 heads come up out of the 40. Determine the null hypothesis. Well, guys, it can only be A or P. I'm saying or P, shoot. It can only be A or C because B and D deal with P hat. We don't need to make a claim about P hat because we know the P hat is 29 out of 40. We don't test that. We see that. We're testing, if we were to flip this coin forever, what percentage would come up heads? So, guys, the correct answer here is going to be P equal 0.50 because we're going to be testing if it's more than 50% of the time. Keep in mind, as I've talked about in previous videos, what you're actually testing goes in the alternative hypothesis. The null hypothesis is the status quo. And the easiest way to think about the null hypothesis is it is always the parameter equal to the value that you are testing. Again, let's say that again. It's the parameter value equal to, the null hypothesis is always equal to the value you are testing in the alternative hypothesis. So guys, the correct answer here has to be C. And then choose the correct answer below for the, what is B for the alternative hypothesis? Well guys, it has to be P, so it has to be either A or C. And we're testing more than 50% of the time, so the alternative hypothesis has to be greater than 0.5. All right, so what you can always tell is it skipped on me, but what you can always tell in your null and alternative hypotheses is, and I've pointed this out before in previous videos, your null hypothesis will always be in this form. This will be your parameter value. This is going to be a letter equal to a value. Your alternative hypothesis is always the same letter that you have here. It is always the same value that you have here, but it's going to be one of these three inequalities. So if you know what you're testing in the alternative hypothesis, you know the value that goes there, it has to go up here too. And again, the letters have to be the same. And guys, don't forget, equal always in the alternative hypothesis, or I'm sorry, equal always in the null hypothesis. All right, a coin is flipped 50 times, lands on heads 14 times. You want to test the hypothesis that the coin does not come up 50% in the long run. Now guys, when I read that, you see that vague does not come up. It doesn't say it doesn't come up because it's more than. It doesn't say it doesn't come up because it's less than in the long run. It just gives you a generic, non-directional, generic does not come up. So guys, I'm already thinking in the alternative hypothesis, I'm going to have a not equal to and not a directional claim of less than or greater than, like we did in the previous problem. So guys, again, I know that my null hypothesis either has to be the second or the third because it has to be P. It can't be P hat. And we are testing the claim about the number 50%. So the 50% has to be included in the null hypothesis. Now, when I go to the alternative hypothesis, okay, what does it tell me to do? Well, okay, that's all it has to do. That's cool. I thought it said to do the alternative. Let me go back and check that out. Question 3. Yeah, I guess that's all we had to do in question 3. All right, question 4. According to a reputable magazine, does that even exist? The dropout rate for all college students with loans is 30%. Suppose that 130 out of 400 random college students with loans drop out, complete parts A through B. So guys, we've got our technology output. We can see that we've done a 1-prop z-test. The test statistic is 1.09 and the p-value is 0.28. So I'm just going to leave this up here while I do this problem. So give the null and alternative hypothesis to test that the dropout rate is not 30%. So guys, I need always equal to, and let's see, is not, so we know that's going to be not equal to, and what goes in here will be our point 30. And if point 30 goes there, point 30 has to go right there. All right, let's check our answer. It's going to be fantastic. All right, that's cool. Report the test statistic from the output given. Well, your test statistic is your z here, and we need to round this, well, as it's presented, so I need 1.0911. Okay. And it's probably going to ask for the p-value next. No, it doesn't. It just lets us go to the next problem. Okay, a taste test is done to see whether a person can tell soda X from soda Y. In each case, 32 random and independent trials are done, half with soda X and half with soda Y, in which the person determines whether she or he is drinking soda X or soda Y. One person gets 20 right out of 32 trials. Which graph shown below is the correct figure to test the hypothesis that the person can tell the difference? Well, guys, to tell the difference, it doesn't mean that we're, indication of higher or lower than. So it would tell me that graph B is the correct figure. The alternative hypothesis would be two-sided. A person can tell the difference between would have a better result than if they were simply guessing. Now let's see let me make sure I understand this question correctly. So actually I'm looking at this as a two-sample problem when we're actually comparing. So guys, I was wrong here. Question A would be the correct figure, because if they were to guess at random, you would expect for them to get 50% right. But if they can really tell the difference, then you would expect for them to get more than 50%, which would be more than 16 out of 32. So guys, I was wrong there. We need a one-side test to see if it's better than actually just guessing. All right, suppose researchers are testing people to see whether the rate of use of seat belts has changed from a previous value of 88%. Again, doesn't say it's changed because it's higher. It doesn't say it's changed because it's lower. It's just that generic changed from a previous value of 0.88 or 88%. Suppose in their random sample of 500 people, they see the 445 of the seatbelt fastened. Which of the following figures has the correct p-value for testing the hypothesis that the proportion who use seatbelts has changed? Well, change doesn't indicate, like the previous problem, that success is higher or lower. Now, you would think that that these vehicle engineers would hope that more people wear seatbelts, because there is a link between traffic fatalities and the use of seatbelts. But it doesn't say that. It just says, have they changed? So graph B would be the correct one, because we don't have a direction of it. The use of seatbelts has either increased or decreased. The alternative hypothesis would be two-sided. Go see if the proportion has changed for better or worse. All right, so these are really pretty easy. It's just, the first time you see this stuff, it can be a little bit confusing. According to a reputable magazine, the percentage of female CEOs in a certain group of high-revenue companies was 4%. Suppose a student did a survey of 250 randomly selected companies, not the group of high-revenue companies, and 20 of them had female CEOs. The null and alternative hypotheses for a test that will test whether the population proportion of female CEOs is not 4%, and they're given. So you have the null hypothesis P equal 0.04, the alternative hypothesis p not equal to 0.04. The conditions for such a test are satisfied. Determine the test statistic and p-value using the technology output provided. Well, guys, from the technology output, the z would be the test statistic. So we want this to 2 decimal places. So the z is going to be 3.23. Find the p-value. Well, the p-value is how many? 3, so we need it out to 0.001. Check it. We know we're going to be right. What is the conclusion to the test? Well, if we're testing at 0.05, which it says right up here, we reject the null when the p-value is less than 0.05, which it is. So we are going to reject the null. So there is sufficient evidence to conclude that the proportion of female CEOs in a large company is what? Well, we can only conclude what's in the alternative hypothesis, which is not equal to. So it's not 0.04. Okay, a poll reported that only 761 out of a total of 1986 adults in a particular region said they had a great deal of confidence or quite a lot of confidence in the public school system. This was down 5 percentage points from the previous year. Conditions are met. Complete parts A through D. Find the 95% confidence interval for the proportion that expresses a great deal of confidence or quite a lot of confidence in public schools and interpret the interval. Well, gang, I'm going to grab my calculator here and make sure the batteries are working. They are. So I'm going to go over to, let me unplug this thing. It's going crazy on me. All right, let me all right, this should do it okay. Now, first thing we want a 95% confidence interval. We see that 761 out of 1986. So guys, what I'm going to do here, I'm going to go to stat, like I've shown you before. I'm going to go over to test, and I am looking for a 1 prop z interval. Now, x is the count out of the whole, which in this case is 761. N is the whole, that's the biggest number always, so that's 1986. And we want our confidence level to be 95. Guys, you can use 0.95 or 95 there. Either one works. So we want to 3 places. So I'm going to go 0.362 up to 0.405. Just rounding each of these to 3 places. Now, it's probably going to have us interpret. So interpret the interval. So we would say that there is a 0.95. Now, we've got to figure out which one of these formats of the interpretation is correct. So the first one's, if we put the 0.95 in the values for the interval, we would say that the sample proportion having a great deal is between, well, guys, clearly not A. We know the sample proportion is between those two numbers because the confidence interval is built around the sample proportion. So A couldn't be true. We are 95% confident that the population proportion of adults having a great deal is between Okay, that seems reasonable. C, we are 95% confident that every sample proportion, well, that's kind of silly. We know that's not the case. D, there's a 95% chance that the population have a great deal or quite a lot of confidence is between. So what do you think? Are we 95% confident, or is there a 95% chance that the population, because it's really only the only difference in B and D. So I'm going to go with B, and I'm going to go 95. And I'm going to tell you right now, I'm going to be wrong. You tell me why. Or am I going to be wrong? Well, you know that I'm not. Okay, so we're 95% confident that the population proportion of adults is between those two values. Find an 80% confidence interval and report it. Well, guys, that's really easy now. All we got to do is go to test, go back to 1 prop z interval. We've got the same information, just change this to 80, calculate, and we've got an 80% confidence interval. So our left bound will be 0.369, assuming that we go to 3 places. And the right bound would be 0.397. Bet you guys wish you'd paid more attention in grade school when you studied rounding, right? Check the answer. It's going to be right unless we did a typo. Interpret this interval. So again, we are looking for the statement about the population proportion. So it looks like A is going to be correct. We are 80% confident that the value is 0.369 and 0.397. Check the answer. Now, find the width of each interval by subtracting the lower proportion from the upper proportion. So the width of the 95% confidence interval is 0.405 minus 0.362. The guys, don't confuse this with the margin of error. This is just the width of the interval. So the width of the 95 is 0.043. And the width of the 80% is 0.028. So the 95% is wider. Let's check our answer, make sure we didn't do a typo or anything. Now, guys, why is that the case? Why is the 80% confidence interval, why is the 95% confidence interval wider? Well, it's because we have more confidence. The more confidence we have in our confidence interval of containing the unknown population, well, the wider we go, the cockier we get, right? The wider we go, we have more confidence that our interval is containing what we look for. It's kind of like this. If I see a student come in here and they're like, well, Dr. Darbro, guess my height. And they tell me, well, I'm just going to give you kind of a margin of error, if you will, width of 1 inch. Well, I'd sit there and look at them. I'd say, well, you're between 61 inches and 62 inches. But what if they give me more margin for error and I go, well, I know you're somewhere between 58 inches and 72 inches. I got more confidence in my second guess because the span of values where I'm making this so-called guess, it's really not a guess, it's an educated guess using statistics, I'm more confident because I have a wider range of values. So how would a 90% confidence interval compare? Well, 90% would be wider than the 85%, but narrower than the 95%. So it looks like to me it would be wider than the 95%, but narrower than the 80%. And I got sloppy. Okay, why not? Why is that? So the 90% would be narrower than the 95%, but wider than the 80%. So, okay, what am I doing here? The 90% would be narrower than the 95%, but wider than the 80% because the interval gets wider. All right, guys, I just got sloppy there. I spoke it correctly. I just got sloppy when I chose my answer. So that's why we have A's are 90 and above, B's are 80 to 90, and so on and so forth. So let's work a similar question. So we're going to do a 99% confidence interval. So here we have 838 out of 2142. And here we want a 99% confidence interval. So the left bound is 0.364. And the right bound is 0.418. Check your answer. Cool. Interpret this interval. So there is a 90, so we are 95% confident that the population proportion. Okay, so guys, B has all the words we need, confident, and it mentions the confidence in terms of the population proportion and not the sample proportion. All right, let's check it. All right, find an 80% confidence interval. Well, guys, let's just go back to where we were. So we have 0.378 as the left bound, and we have 0.405 as the right bound. So guys, what are we looking for? We're looking for the confidence. We know it's either C or D, and we want the confidence stated about the population proportion, not a sample, so we know the correct answer is D. So we are 80% confident, 0.378, and 0.405. Check our answer. We know we're going to be right. Now it gets into the one where I was a bonehead. The width of the 99% is 0.054. The width of the 80% is 0.027. So the 99% is wider. Now let's not get sloppy here, okay? How would a 95% interval compare with the others in width? Well, guys, the 95% is going to be narrower than the 99%, but wider than the 80% because as intervals get wider with increasing confidence level. So it really, really, really helps if you read the entire answer and not get sloppy like I did before. All right. In 2008 survey, people were asked their opinions on astrology, whether it was very scientific, somewhat scientific, or not at all scientific. Of 1433 who responded, 76 said astrology was very scientific. Okay? So find the proportion of people in the survey who believe astrology is very scientific. Well, guys, it's easy. Just take 76 divided by the 1433. We want to report this to 4 decimal places, so that'll be 0.0530. Construct the 95% confidence interval. Guys, we should be really good at this by now. So what do we have? 76, 1433. We want a 95% confidence interval. So we need to round to 3 places. So this will be 0.041. And the right is 0.065. Okay, next question, 1 part remaining. Choose the correct answer below. This is plausible. Now, so part C says, suppose a TV news anchor said that 5% of people in the general population think astrology is very scientific. Would you say this is plausible? Well, what I want to look for is I want to see if this particular claim by this particular TV news anchor of 5% is contained in my interval. If it's contained in my interval, then their claim is believable to me somewhat. If it's not contained in the interval, then I conclude it's not plausible. Since 5%, 0.05, is contained in this interval, then I'm either going with A or D. And I'm saying it's plausible because 5% is in the interval. And I want to teach on this just a second and show you something over here on the side. Okay. Now, gang, before we go over to the 10th question, I want to come over here and show you some stuff. Now, let's say a news anchor makes a claim that the percentage of whatever is 8%. And I construct the following 95% confidence intervals. I do this one. Now, what do these tell us? Well, first of all, I look at the 8%. I think of that as 0.08. In the first interval, the 0.08 is between 0.065 and 0.092, so the claim is contained, so it's plausible. Notice in the second interval that the 0.043 and 0.056 that the 0.08 is not contained. So it's not plausible. Notice the 0.092, the 0.115, 0.08 is not contained in there. Also not plausible. But guys, there's more. Notice that this entire interval, 0.043 to 0.056, is below the claim. So we can say not plausible because the value is below. the p-value that we're trying to estimate, this new p-value, we're estimating with this confidence interval. Our estimate is totally below this claim up here. So I would say that the true p-value is below the claim of 8%. On the other hand, notice that the 0.08, not contained in here, but this entire interval, which is being used to estimate the value of p, the new value of p. So I'm saying that the new value of p is higher than the claim of 8% because our entire interval is above the claim of 0.08. So not plausible because the p-value appears higher than the claim of 8%. Now, sometimes you get into something like this. Notice that the 0.081 is just barely above the 0.08. Doesn't matter. It's still not plausible because the entire interval is above the claim amount. Okay. Now, this one is said in a survey. People were asked whether they thought sun went around the planet Earth or vice versa. That's kind of funny. I'm sorry. Of 1,902 people, 383 thought the sun went around the Earth. Okay, there you go. What proportion of people in the survey believed the sun went around the Earth? It kind of reminds me of some of those. Jay Leno used to go out on and interview people. Oh well, anyway, I'm sorry. I'm entertained by stuff. Alrighty, let's work the problem. So what proportion of people in the survey believe the sun went around the Earth? So that's going to be 383 divided by 1902. So I have to see what they want me to round to, 3 places. So I'm going to have 0.201. The 95% confidence interval. You guys remember that 0.201, and I want to show you something here in just a second. That answer is actually provided to you in your output here. So we have 383, 1902, and we want a 95% confidence interval. Now, if you look at that, this p hat right here is 0.201, which we got earlier just by executing that proportion on the home screen. So your p hat, your sample proportion that we answered in part A, is always given to you in this output. But anyway, it's asking for the confidence interval. So 0.183 looks like the left bound. And the right bound looks like to me it's 0.219. Is the scientist's claim that 30% of the people in the general population believe the sun goes around the Earth plausible? Well, is 30% in your interval? It is not. So it's not plausible since the value, 0.30, is not inside the confidence interval. All right, gang, that looks like it's it. We did pretty well here, except for my bonehead moment back there where I didn't completely read the responses. So, gang, I hope this helps. I believe it will. Guys, hang in there. Take care.